In this video, we are going to talk about differential equations. So we'll be talking about how to distinguish between ordinary differential equations and partial differential equations. We'll also talk about linear and nonlinear equations. Then we'll talk about solutions of differential equations. So a differential equation is any equation that involves the derivative of one or more dependent variables with respect to one or more independent variable. Now, let's differentiate between ordinary differential equations, which I will shorten as ODE, and partial differential equations. The major difference is that with the ordinary differential equations, the independent variable is only one variable. But for the partial differential equations, the independent variable is more than one variable. And also, another significant difference is that with the ordinary differential equations, it is normally represented with a total derivative, which is, for example, dy dx. And then for the partial differential equations, it's normally represented with this kind of derivative, for example, dy dx. And then, so in this case, since it is more than one variable, you get maybe dy dx, then you get another variable. So this is the major difference between an ordinary differential equation and partial differential equation. So for example, for a partial differential equation, you can also get du dy equals dv dx. So you see that the independent variables here are y and x, and then the dependent variables here are u and v. But for example, if you get a differential equation like dy dx equals sine x, then you see that the independent variable here is only one, which is x, and therefore this is an ordinary differential equation, and this is a partial differential equation. Now let's talk about the linear and then nonlinear differential equations. There are two major points to consider to be able to determine the difference between a linear and then a nonlinear differential equation. The first is that all the powers of the dependent variable and its derivative must be of degree 1. And then the second one is that the coefficients must depend on only the independent variable. So let's take some examples and understand the differences between linear and nonlinear differential equation. So for example, if you have a differential equation like this, s cubed, then dqy dx cubed plus 4x dy dx, and then plus 6y equals exponent x. You see that with this differential equation, all y and its derivative are all 1. Here is y exponent 1, y exponent 1, y exponent 1. Sorry, I mean exponent 1, not prime. So therefore, it satisfies the first condition that the dependent variable and all its derivative must be of the first degree. And then the second part is that all the coefficients must be dependent on the independent variable. So you see that here is x cubed, here is 4x, and here is 6. And therefore, this is a linear differential equation. Now, let's take another example. Now, this example, this is not a linear differential equation. This is nonlinear differential equation. The reason is because the dependent variable is of the degree 2. So you see that here is y squared, and because of that, this is nonlinear. So let's also consider this differential equation. Now, this is also a nonlinear differential equation. The reason is because the coefficients are dependent on the dependent variable. Because the rule says that the coefficient should be dependent on the independent variable. But here, the coefficient is dependent on the dependent variable, and therefore this is a nonlinear differential equation. So let's talk about the applications. Differential equations are usually applied in projectile motions So they are used to analyze projectile motions and also planetary motions. And then they are also used to analyze circuit problems. And then vibrations in a wire. And then they are also used in chemical kinetics to determine rates and half-life of chemical reactions. And then the last one is they are also used in geometry. So these are the various areas in which differential equations could be applied. And we have a question here. Classify each of the following equations as ordinary or partial differential equations. State the order of each equation and determine whether the equation of consideration is linear or nonlinear. So let's consider the first equation. This is dy dx plus x squared y is equal to x exponent x. So now, the first thing is we are supposed to determine whether it is an ordinary differential equation or a partial differential equation. If you check here, the independent variable is x only, and because the independent variable is only one, this is an ordinary differential equation. So the first thing is that this one is ordinary. And then the second part is we are supposed to determine the order of the differential equation. The order of the differential equation is the highest power of the derivative. So for example, in this case, this is first order because dy dx is 1. Now, for example, if it was d squared y dx squared, then this will be second order. And if it was d cubed y dx cubed, then this will be third order in that function. So that is how to determine the order of a differential equation. So this is a first order. And then the last part is we are supposed to determine whether this is linear or nonlinear. Now, by looking through, you see that all the coefficients are dependent on the independent variable. And also, the dependent variable, which in this case is y, and its derivatives are all of the first order. And therefore, this is a linear differential equation. So let's come to this second one. You see that the independent variable is only one, which is x, and therefore this is an ordinary differential equation. The second thing is that we are supposed to determine whether it is the second part, which is the order. You see that this is d cubed y dx cubed, so this is a third order. And then the last thing is whether it is linear or non-linear. You see that the dependent variable are all of the first degree, and also the coefficient, see the coefficient here, are all dependent on the independent variable, which is x, and therefore this is also a linear differential equation. Let's come to this place. Now immediately you see this kind of derivative, then you should know outright that this is a partial differential equation because the independent variables are 2, x and y. And then the order is, you see that this is d squared u dx squared, so this is second order. And then the last thing is that this is also linear. This is a linear differential equation. Let's come to this place. Now with this one you can rewrite it, but if we rewrite it, it will become x squared dy dx, that is we are dividing through by dx, then plus y squared is equal to 0. So we've rewritten it in this form. So you can see that this is an ordinary differential equation. And then the second thing is that the order, this is dy dx, so this is first order. And then the last one is whether it's linear or non-linear. Now this is non-linear. It is non-linear because of y squared. The dependent variable, the rule says must be of the first order, but this is of the second, must be of the first degree, but this is of the second degree, and therefore this is non-linear. Let's come here. Now you can see that this is also an ordinary differential equation. Then the second thing is the order. The order here is fourth order. So this is a fourth order differential equation. And then whether it is linear or non-linear. Now, this is a linear differential equation. Let's come to this case. D squared y dx squared plus y sine x is equal to 0. So you can see that this is an ordinary differential equation. And then the order is a second order because it's d squared. So this is a second order because of these two. And then the last thing is that this is also a linear differential equation. Let's consider this one. This is also an ordinary differential equation. And then this is also the second order. But this is non-linear. This is not a linear differential equation because of sine y. So this is non-linear differential equation. Now if we come to this case, see that this one is a partial differential equation. And then the order is a fourth order differential equation. But then this is a linear differential equation. Then let's talk about the last one. Now you see that this is an ordinary differential equation. And then the order, this first order, because it's the RDS. So this is a first order differential equation. And then it is non-linear. Remember we said that the dependent variable and its derivative must be of the first degree. But if you check here, this is of the third degree. And therefore, this is non-linear differential equation. So this is how you can differentiate between linear and then non-linear differential equations. Also determine the order and then whether it is an ordinary or a partial differential equation. So let's talk about the solutions of a differential equation. The solutions of a differential equation is a function which, when substituted into the differential equation, reduces it to an identity. So, for example, let's take this question and then we can understand what the solutions are. So he says that show that the functions f defined for all real x by f of x equals 2 sine x plus 3 cos x is an explicit solution of the differential equation d squared y dx squared plus y equals 0. So what it means is that if we take this function and we apply this differential equation to it, we must get 0. So let's let y to be equal to 2 sine x plus 3 cos x. And then you see that this is d squared y dx squared. So that's the second order. But first, let's find the y dx. So if you differentiate sine x, you get cos x. So this becomes 2 cos x. And if you differentiate cos x, you get minus sine x. So minus 3 sine x. So this is the y dx. Now let's evaluate d squared y dx squared. That means we should take the y dx and differentiate it further. If you differentiate cos x, you get minus sine x. So this becomes minus 2 sine x. And if you differentiate sine x, you get cos x. So this becomes minus 3 cos x. Now, the differential equation is d squared y dx squared then plus y is equal to 0. So let's evaluate it. We know that d squared y dx squared is all of this. So let's take this, which is minus 2 sine x minus 3 cos x. Then we have plus y, but we said y is 2 sine x plus 3 cos x. Now let's group like terms. So we have minus 2 sine x then plus 2 sine x then minus 3 cos x plus 3 cos x. So you see that this will evaluate to 0 and this will evaluate to 0. So all of this is equal to 0. And because if we use this function f of x and we put it in this differential equation, we get 0. It means that f of x equals 2 sine x plus 3 cos x is a solution of this differential equation. Show that the function defined by f of x equals 2 exponent 3x minus 5 exponent 4x is a solution of d squared y dx squared minus 7 dy dx plus 12y equals 0. So the function is f of x equals 2 exponent 3x minus 5 exponent 4x. So let's let y to equal to 2 exponent 3x minus 5 exponent 4x. So you see that the order of this differential equation is the second order. So let's first find dy dx, and that is equal to, now if you differentiate exponent x, you first differentiate the function on top. If you differentiate 3x, you get 3. So 3 times 2 is 6. So we have 6 exponent 3x. Then we'll do similar thing here. If you differentiate 4x, you get 4. 4 times minus 5 is minus 20 exponent 4x. Then now, let's do d squared y dx squared. This is equal to, now if you differentiate 3x, you get 3 times 6. It becomes 18 exponent 3x. And then if you differentiate 4x, you get 4. 4 times 20 is minus 20 becomes minus 80 exponent 4x. So now, we can take all of this and put it into that equation over there. So let's continue from here. So you can see that the equation is d squared y dx squared, then minus 7 dy dx, then plus 12y is equal to 0. But we found d squared y dy dx, which is this. So let's bring it here. So it is 18 exponent 3x minus 80 exponent 4x. Then we have minus 7 dy dx. This is dy dx, and that is 6 exponent 3x minus 20 exponent 4x. Then plus 12 times y. Y was what we were given initially, which is 2 exponent 3x minus 5 exponent 4x. So this is equal to 18 exponent 3x minus 80 exponent 4x. Now minus 7 times 6 is minus 42. So here becomes minus 42 exponent 3x. Then minus 7 times minus 20 is plus 140 exponent 4x. Then 12 times 2 is 24. So here becomes plus 24 exponent 3x. Then 12 times minus 5 is minus 60 exponent 4x. So let's group like terms. So we have 18 exponent 3x, then minus 42 exponent 3x. Then we have plus 24 exponent 3x. Then here we have minus 80 exponent 4x. And then here is also plus 140 exponent 4x. Then minus 60 exponent 4x. And this is equal to, you see that 18 plus 24 is 42. So here becomes 42 exponent 3x minus 42 exponent 3x in one bracket, then plus. Now minus 80 minus 60 is minus 140 exponent 4x and plus 140 exponent 4x. So you see that here is 0 plus 0, which is equal to 0. And therefore, since this satisfies this equation, it means that f of x is a true solution of this differential equation. So that every function f defined by f of x equals 2 plus c exponent minus 2x squared, where c is an arbitrary constant, is a solution of the differential equation dy dx plus 4xy is equal to 8x. So let's let y to equal to 2 plus c exponent minus 2x squared. So dy dx in this case is equal to Now if you differentiate 2 is a constant, so it's 0. Now in differentiating this, the first thing is we need to differentiate what is inside the exponent, and that is minus 2x squared. Now if you differentiate minus 2x squared, you get minus 4x. So here is minus 4x, c, then exponent, whatever is there, minus 2x squared. Now, so here, this one is of the first order. So what we do is that we put it into this equation. So dy dx, this is dy dx, minus 4x, c exponent minus 2x squared, then plus 4x times y. Y is giving us 2 plus c exponent minus 2x squared. Now this is minus 4x c exponent minus 2x squared, then plus 4x times 2 is 8x, then plus 4x times all of this becomes 4x c exponent minus 2x squared. So you see that here is minus 4x c exponent minus 2x squared, here is plus 4x c exponent minus 2x squared, and therefore that will evaluate to 0. So this is equal to 8x, and that is exactly what we're supposed to prove. And for that reason, f of x equals 2 plus c exponent minus 2x squared is a true solution of. So we have this question here which says that for certain values of the constant m, the function f defined by f of x equals exponent mx is a solution of the differential equation, which is d cubed y dx cubed minus 2 d squared y dx squared minus 4 dy dx plus 8y is equal to 0. So the question is saying we should determine all such values of m. So let's let y to be equal to exponent mx. So let's find dy dx. So you differentiate what is inside the exponent. If you differentiate mx, you get m. So here's m exponent mx. And let's find d squared y dx squared. That is equal to, differentiate this again, you get m. M times m becomes m squared exponent mx. And then now we are going to, because the differential equation is the third order, so we must do another one. So this becomes, so d cubed y dx squared is equal to, differentiate this again, you get m. M times m squared becomes m cubed exponent mx. So we can now put all of this into this equation. Remember that the equation is d cubed y dx cubed minus 2 d squared y dx squared, then minus 4 dy dx plus 8y is equal to 0. So d cubed y dx cubed is all of this. Sorry, here's x cubed. Is all of this. So it is m cubed exponent mx. Then minus 2 d squared y dx squared is all of this, which is m squared exponent mx. And then minus 4, this is dy dx, m exponent mx. Then plus 8y, y is exponent mx. Then this, all of this is equal to 0. So let's expand. Here becomes m cubed exponent mx, then minus 2m squared exponent mx, then minus 4m exponent mx plus 8 exponent mx is equal to 0. So let's factorize exponent mx. So if we factorize exponent mx out, we'll be left with m cubed here minus 2m squared minus 4m plus 8 is equal to 0. Now, exponent mx can never be 0. This one can never be equal to 0. So the only thing that can be 0 is all of these brackets. So what we need to make this 0 is when m cubed minus 2m squared minus 4m plus 8 is equal to 0. So let's test, let's put in minus 2. m equals minus 2. Sorry, so let's put m equals minus 2 into this equation and see whether we'll get 0. So minus 2 cubed minus 2 times minus 2 squared minus 4 times minus 2 plus 8 is equal to 0. Sorry, plus 8. Then now, minus 2 cubed is minus 8. Then minus 2 squared is 4 times minus 2. That also becomes minus 8. Then minus 4 times minus 2 becomes plus 8. And then we already have plus 8 here. So minus 8 is minus 16. Plus 8 is 16. Minus 16 plus 16 is 0. So since m equals minus 2 gives us 0, it means that m plus 2 is a factor. So since it's a factor, what we can do is that we can divide. So here will be m plus 2. And then here is m cubed minus 2m squared, then minus 4m plus 8. So you see that if we multiply m squared by m, we get m cubed. So here is m cubed. Then m squared times 2 becomes plus 2m squared. So if we subtract this, minus this plus m cubed minus m cubed will give you 0. Minus 2m squared minus 2m squared becomes minus 4m squared minus 4m plus 8. So here we can put minus m here. So that, sorry, minus 4m here. So that minus 4m times m becomes minus 4m squared. Minus 4m times 2 becomes minus 8m. So if we do this subtraction, here becomes 0. Minus 4m minus 8m becomes 4m plus 8. So here we can put plus 4 here. 4 times 4m becomes 4m. 4 times 2 becomes 8. And if we subtract this, this is equal to 0. So what it means is that the factors of m, so we can rewrite it as m plus 2 times all of this, which is m squared minus 4m plus 4 is equal to 0. Now, how do we factorize this? Two numbers that when we multiply, you get plus 4, but when we add, we get minus 4. So you see that minus 2 times minus 2 is minus 4. Sorry, is plus 4, but minus 2 plus minus 3 is minus 4. And therefore, we have m plus 2, then m minus 2, but this will be a repeated root, times m minus 2 is equal to 0. So the values of m are m equals minus 2 or m equals 2. So these are the values of m that will satisfy this differential equation. For certain values of the constant n, the function g defined by g of x equals x exponent n is a solution of the differential equation x cubed d cubed y dx cubed plus 2x squared d squared y dx squared minus 10x dy dx minus 8y is equal to 0. Determine all such values of n. So let's let y to be equal to x exponent n. So let's find dy dx. This is equal to n x exponent n minus 1. Let's find d squared y dx squared. So bring n minus 1 down. So it becomes n times n minus 1. Then x exponent n minus 2. Then let's find d cubed y dx cubed. This is equal to, now bring n minus 2 down. So it becomes n times n minus 1 times n minus 2. Then x exponent n minus 3. So we'll take all of this and dump it into this equation. So we will now have x cubed, then times the third derivative. The third derivative is n times n minus 1 times n minus 2, then times x exponent n minus 3, then plus 2x squared. Then the second derivative is this one, which is n times n minus 1 x exponent n minus 2, then minus 10x, the first derivative, which is dy dx, and that is n x exponent n minus 1, then minus 8, then y was given as x exponent n. All of this is equal to 0. So if we push in x, you see that x exponent n minus 3 times x cubed will give us x exponent n. So here becomes n minus 1, n minus 2, then x exponent n, plus, now if we push this x squared inside, you see that x exponent n minus 2 times x squared is x exponent n. So this one will give us 2n times n minus 1, then x exponent n. Then here too, x times x exponent n minus 1 is the same as x exponent n. So here we'll get minus 10 n x exponent n, then minus 8 x exponent n is equal to 0. So we can factorize x exponent n. So if we factorize x exponent n, we will be left with, now we can evaluate this n times, so n times n is n squared, then n times minus 2 is minus 2n, minus 1 times n is minus n, minus 2n minus n becomes minus 3n, then minus 1 times minus 2 becomes plus 2, then plus 2, now n times n is n squared, then n times minus 1 is minus n, then here is minus 10n minus 8. All of this is equal to 0. So you see that x exponent n can never be 0. The only thing that can be 0 is what is inside this bracket. So it means that we should equate all of this to 0. So n, so now let's multiply. N times n squared is n cubed. Then n times minus 3n is minus 3n squared. N times 2 becomes plus 2n. And then plus 2 times n squared becomes 2n squared. 2 times minus n is minus 2n. Then minus 10n minus 8 equals 0. So you see that there is plus 2n here, minus 2n, they can cancel. Now, minus 3n squared plus 2n squared is minus n. So we have n cubed minus, is minus n squared. So minus n squared, then minus 10n minus 8 is equal to 0. So in this case, let's test for n equals minus 1. So if we put in minus 1, here become minus 1 cubed, then minus 1 squared, minus 10 times minus 1, minus 8 is equal to 0. Minus 1 cubed is minus 1. Then minus 1 squared is 1 times minus 1 becomes minus 1. Minus 10 times minus 1 becomes plus 10. Minus 8 is equal to 0. Now here it becomes minus 1 is minus 2. Minus 2 plus 10 is 8. 8 minus 10. So that will give us 0. So this is equal to 0. Sorry, I had to remove this. So all of this will evaluate to 0. So what it means is that n plus 1 is a factor of that equation. So let's divide the polynomial by n plus 1. So here is n cubed minus, n cubed. Let me do this. N plus 1 is here. Then we have n cubed, then minus n squared minus 10n minus 8. So if we put n squared here, n squared times n is n cubed. N squared times 1 is plus n squared. So if we subtract, minus n squared becomes minus 2n squared minus 10n minus 8. Then Let's put minus 2n here. So minus 2n times n becomes minus 2n squared. Then minus 2n times 1 becomes minus 2n. Now minus 2n squared minus 2n squared is 0. Then here minus 10n minus minus 2n is the same as minus 10n plus 2n. And that will give us minus 8n minus 8. So we put minus 8 here. So that minus 8 times n becomes minus 8n. Then minus 8 times 1 is minus 8. So this will evaluate to 0. So it means that, let me write it here. So it means that this quadratic becomes, it means that this polynomial becomes n plus 1 then times n squared minus 2n minus 8 equals 0. So two numbers that when we multiply, we'll get minus 8. But when we add, we get minus 2. So those numbers are minus 4 and 2. Minus 4 times 2 is minus 8. Minus 4 plus 2 is minus 2. So we now have n minus 1, then n plus 2, and then n minus 4 equals 0. So the values of n are n equals minus 2, n equals 1, and then n equals 4. Sorry, I made a mistake. Here's n plus 1, and therefore this is going to be n equals minus 1. So it is n equals minus 2, n equals minus 1, and n equals 4.